organize quantitative data. Quantitative, quantity, so we're kind of dealing with numerical data here, okay? Objective, organize quantitative data in tables. So let's remind ourselves what we know that will be helpful for this lesson. We know what quantitative or numerical data is. Data that provide numerical measurements or measures. Okay, what we know about quantitative data is that arithmetic operations can be performed, and that will provide us with some meaningful results. Within quantitative data, we have two types. We have discrete variables, a quantitative variable that has either a finite number of possible values or a countable number of possible values. A discrete variable cannot take on every possible value between any two possible values. So how many pizza slices did you eat? You ate 1, or you ate 2, or you ate 3. We're counting number of pizza slices. A continuous variable, a quantitative variable that has an infinite number of possible values that are not countable. Okay, a continuous variable may take on every possible value between any two values. Okay, just a reminder of some vocabulary up here. We've also dealt with frequency distributions, a list of each category of data and the number of occurrences or the count for each category. And we've dealt with relative frequency distributions, a list of each category and the percentage as a decimal of the occurrences for each category. As a reminder, the sum of the relative frequencies always sums to 1, which is because it's the percent as a decimal, 1 is the same as 100%. We want all the data to be included. Okay, if the data are discrete with relatively few values of the variable, then the categories of data, which are called classes, will be the observations, just like in quantitative data. Let's take a look at that. Got an example here. Right, once I get it ready, comes from our textbook. The manager of Wendy's wants to know the typical number of passengers who arrive during the lunch hour. The table below represents the number of customers who arrive at Wendy's for 40 randomly selected 15-minute intervals during lunch. Okay, for example, during one 15-minute interval, 7 customers arrived. Okay, we want to construct a frequency and a relative frequency table of the data, and then we want to create this and show the same thing in StatCrunch using stat tables frequency. Okay, notice our data is only going, our numbers are only going from 1 to 11. That's our high and our low. So we can just list these numbers of customers from 1 to 11. We don't need to create categories. We can just list them. So I think I can get all that in there, maybe. Okay, so number of customers, we either had 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, or 11 customers. We go into here and we tally them up. How many times did 1 occur? 1 customer in a 15-minute interval took place once. 2 customers, as we go through and tally them, we have 6 examples of that. 1 example of this one, 4 examples of 4 customers. We had 7 15-minute periods, 15-minute intervals in which 5 customers arrived. 11 for 6. We can tally, as we count, we tally those up. Kind of go through and count the number of 6s up. 7 was for 5. 8, 2. 9, also 2. 10 had no tallies, and 11 was 1. Okay, so we can tallies as we're, as somebody's giving us information, we're tallying up. Now we're going to write these as numbers. The frequency 1, 6, 1, 4. Let me just check, make sure that I'm not, check my notes as well. 7, 11, 5, 2, 2, 0, 1. And we want to check. Go up to here. 40 randomly selected intervals. So we better have 40 when we add up all these numbers, and we do. And now let's create the relative frequency. So this is 1 out of 40. The relative frequency is a percent as a decimal. 1 out of 40 is 0.025 when you put it into a calculator. And again, as a percent, that's going to be 2.5% of the time, but we're looking at this as a decimal. I won't copy this again. We've already done this. I'll just put the relative frequencies down. 0.15. 1 we already know. 0.025. Again, I've already done the math. 0.1. 0.175. 0.275. 0.125. For 2, it's 0.05, I think. Yes. 0.05. 0, of course, is 0. And then we've already done the 1. We have 0.025. And when we add up all of our relative frequencies, we better have a sum of 1. Okay, kind of keeping track of ourselves. Did we include everything? If our sum of our relative frequencies is 1 or 100%, we've got it all. Okay, now as I mentioned, the data is here in StatCrunch. Let's use it to validate our table. Okay, so we'll go to StatCrunch and look at our data, textbook data sets. We're in chapter 2. I said 2_2. Table 8, here it is right there. So I'll click there. Okay, there's all of our arrivals from 7. They went down. They went column by column. Okay, so use StatCrunch stat tables, and we're looking for the frequency table again. Okay, our columns are the arrivals. Okay, and group by, what are we grouping by? Oh, well, group by arrivals. Statistic, what is that telling me? Oh, yeah, what do I want? I'll do both the relative and the frequency here. They're defaulting. I like to order by the worksheet unless I want to order by ascending or descending. And let's compute. And just a second, something didn't work there. Let's go back to edit. And maybe I don't want to group by. That's probably what I did. I don't want to group by because I think it grouped them and I don't want that to happen. Yeah, it did group them. So I take that away. Here's our arrival numbers. They have the arrivals not 1 through, but they've done it with, as they saw it in the table. I saw it in the table. There's our frequency and there's our relative frequency, just like we have. And let's note that we have a count of 40. Okay, we're going to now go into, continue on. Give me a moment here. Okay, so that was data that was discrete, but we only had a few values. We just had 1 through 11 customers. Okay, what happens if the data are discrete, but we have many different values? Okay, or if the data are continuous? If that's the case, we need to categorize them. Our classes need to be creating using intervals of numbers instead of just a single number. Okay, each interval has a lower class limit and an upper class limit, and then it has a consistent class width. So the lower class limit is the smallest value of the class. The upper class limit is the largest value within the class, and then the class width is the difference between 2 consecutive lower or 2 consecutive upper class limits. This is the one that throws students when you look at class width. You need to subtract lower from lower or upper from upper to get the correct class width. Well, how do we do this? How do we determine the lower class limit for the first class, and how do we determine the class width? Well, the lower class choose the smallest observation in the data set or a convenient number that is slightly lower than the smallest observation. So if the smallest observation is 17, you may want to choose 15 because it's nicer to work by 5s, or you might want to choose 10 because it's nicer to work by tens in that case, for example. The class width, this is kind of a guessing and checking idea here. How many classes do you want? How does it look? Generally, we're looking for between 5 and 20 classes, but it really depends on how much detail you're looking for. And as you work with that, you might want to try several class widths to see how the data looks as you're presenting it. How do you determine it? Your class width is the largest data value minus the smallest data value divided by the number of classes you want to have. Round up. Round your class width up to a convenient number that is easy to work with. Again, with class width, you're probably looking to work with class widths of 10s, widths of 25s, widths of 50s, widths of 100s, maybe widths of 250s, maybe 500s. Depends on your data, obviously, but you're trying to keep things with numbers that we all recognize and can work with fairly easily. Okay, there's no reason to have a class width of, 3, unless your classes are, unless you're pretty tight and, and counting by 3s makes sense, but generally speaking, you may choose to count by 5s, for example. But these tend to be, particularly, a class width of 52. Makes no sense. Go with 50 and be good with that, okay? So now, let's take a look at how this works, both in the table and with StatCrunch. Give me just a second here. Okay. The data in the table below represent the total fine, including late penalties, in dollars for a simple random sample of 50 parking and camera violations in New York City. So here we have it. We've done a sample, a random sample of 50 parking and camera violations. Here are my 50 data points. These are the fines for those 50, I guess they'd be 50 people that we caught and we took their data. Okay, so $211.09. Again, total fine including late penalties, $150.56, $256.70, etc., etc. Obviously, we've got quite a spread here. Give me a moment and I can pick out the low. The low is here at $65, and the high as you work through is $322.61. So we got quite a spread of data, lots of numbers. We're not going to list these all individually. That makes no sense. So we want to list them with intervals. We want to construct a frequency and relative frequency table of the data, and then go into StatsCrunch and do the same thing. Okay, so what is our lower limit? Well, our lowest number, okay, is 65. We want to be at that number or below with a number that we kind of can add to, make a width that makes sense. So let's go with a lower limit of 50. Okay, now you can probably look at this and say, well, I'm going to go to 65 to 322. It probably makes sense to count by 25s or maybe 50s. Okay, using the formula we were given, and I've kind of already done this, and I'm kind of following your book on this. Basically, what the formula says is take the highest, which is 322.61, subtract the lowest, and divide it by the number of classes you're looking for. Well, I wanted it to come out with a nice answer, as did the book. So I knew I'm going to divide it into 11 classes. Okay, 11 classes. Now that's kind of strange to the, I kind of know this, but this is kind of guess and check as you work with it. What do we come up with when we do this? We get the number 23.42, and we say, hey, I want to go slightly above that. Let's have our class width be 25. This is more of an art. There's no real specific way to say always do this. I kind of tend to look, 65 to 322, I want between 5 and 20 classes. Counting by 5s isn't going to get me anywhere. Counting by 10s will take a while. My next choice is kind of 25. If I count by 25s, how many 25s are in there? It looks like about 11, and that's between 5 and 20. That's pretty good. That's kind of what I do, but this is how the book teaches how you do with this. You could say, I want to count. You might want to say, okay, 50 to 100, 100 to 150. Does that give you enough classes? It does. It gives you fewer classes, but that may be something that works for you. Let's do this. So I want the class width of 25. So let's list these. So my first class is going to go from $50 and it's going to end at $74.99. Now notice, here's my class width. Lower minus lower. I can't go to 75 because I can't repeat the number 75 twice. I gotta put $75 in one class or the other. So this one stops at $74.99. My class width is 25. So if I start at 50, my next class will start at 75, which means this one ends at $74.99. And I could continue. This is 100. This is 125. Notice my class width here. This is 150, 175, 200, 225, 250, 275, and then 300. Okay, so here's my 25 class width. If this one starts at 75, this one, because it's money, must end at $74.99, so I don't have an overlap. If this one starts at 100, this one ends at $99.99, and we can go down with the same idea. $124.99, $149.99, $174.99, $199.99, $224.99, $249.99, $274.99, $299. My handwriting is getting a little sloppier, it looks like. And then finally, $324.99. Now we want to make sure. Here is our largest value, $322.61. It's in there. It's right below $324.99. And you can see if we subtract our upper limits, $99.99 minus $74.99 is 25, and that's our class width. So that's what you're looking to do here. Don't want any overlap, and you want to see either in your beginning column, if you subtract high minus low, or your upper column, if you subtract high minus low. That should give you the identical class width, okay? Now again, notice we could have gone from 50 to 99.99, from 100 to 140, from 100 to 149.99, 150. We could have gone by 50s. I think we would have wound up with 6 class widths, which is certainly between 5 and 20. It would have given us fewer categories, good and bad. More categories might be better when you display the information. Fewer categories might be better. It kind of depends on what you're after when you display the data. If we tally these, so how many of our data points are between this? Well, I found 1, frequency of 1. There were none here between 75 and 99.99. Between 100, we had 1, 2, 3, 4. We had 7. In this category, we have 10. So kind of following through the idea of, somebody's reading them off to you, so you're just tallying them up, and then you're writing down the actual number of the tallies. This one is 5. This one is 4. Okay, this one is 13. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. This one 4. This one 5. This one 0, no tallies, and this one 1. Okay, let's remind ourselves, kind of repeating some things here. Our frequency, we add up all these numbers. Well, we go back to here and it says that we took a simple random sample of 50. So we should go down to here and we should make sure 1, 8, 18, 23, 27, 40, 44, 49, 50. We should make sure that we have them all. Okay, relative frequency. Well, we have a total of 50. Relative frequency is the percentage as a decimal. Well, this one takes place 1/50th of this one. In this category, the frequency is 1 out of 50. 1 out of 50 as a decimal is 0.02. And again, as a percent, that's 2%. So 2% of our 50 fines took place, are between $50 and $74.99. Continuing, that's 0. I've already done the math, but you can do the same thing that we've done. This relative frequency is 0.14. This one is 0.20. This one is 0.1. This one is 0.08. This one is almost a quarter, 0.26. 4 is a repeat, 0.08. 5 is a repeat from above, that there, so I already know it. There's a 0, and I've already done 1.02. Okay, let's check ourselves again. If we add up our relative frequencies, we should have included everything, and our total should be a 1. In percentage terms, that is 100%. We want everybody there. Okay, so we want to go into, so that's our, we've made it by hand. Let's go into part B here, and part B says the data are located here, 22 table 12. Let's use stat tables frequencies. We're going to check and we got to check and fill in the bin number values box to create and validate our table. So let's do that. Nice to have technology, that's for sure. So let's see here, chapter 2, 2 table 12 is right here. Okay, so here are all of our fines in column number 1. We're going to go to stat tables and we're going to choose frequency. Okay, select our column, of course, that's our fines. Okay, group by, well, I think this is optional. Yeah, let's not group them because we want to see them all in one place. Statistics. It's already, in my case, it's already defaulting to these 2. We have some other options here, but we want those 2. I tend to like to order by worksheet. Okay, so now we need to tell it where to start, and we need to tell it the class width in order for it to do, for StatCrunch to do it correctly. So let's check that box, and let's tell it to start at 50, and let's tell it that the class width is 25. Okay, and then we can create this, and there we have it. Now, so here are our categories. Here are our intervals, 50 to 75, 100 to 125. Here's our frequency, here's our relative frequency, and if we look at our, what we came up by hand, we see the same thing. Now I want to note one thing here. They've used interval notation. The bracket indicates include, so 50 is included. The parenthesis is a up to but don't include. Okay, up to but do not include. So we have 125 is listed here, but it says go up to it, but with a parenthesis, do not include it. The 125 here has a bracket, so that means the 125 is included. Go up to 150, but do not include 150. So that's what they've done here with interval notation. We'll also notice that they did not include the 0 values. We had no data points between 75 and 99.99, and we had no data points between 275 and 299.99, and they simply did not include it here. Otherwise, our table matches what we get in StatCrunch.